Hello friends, welcome to Learner's Planet. Friends, this is our second session for permutation and combination. In the previous session, we discussed the concept of factorial and we discussed the principle of counting as well. And 2-3 problems also were discussed. In this session, I'll be taking some problems based on principle of counting. So let's begin the session. And do revise the previous session before you come to this particular session, right? Now friends, in the last session, I asked you about how many 5-digit numbers are there in all, right? Then we discussed about how many 5-digit numbers are there with all digits different, then how many 5-digit numbers are there at least one digit is repeated. Now just have a quick recap with this question. How many 9-digit numbers of different digits can be formed, right? The case is like quite similar to the previous one. Now we have the 9 places, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now at the first place, how many choices I have? In all, I have 0 to 9, that means 10 choices. But to make 9-digit numbers, the first I have 9 places, but 0 cannot come on the first place because it will be then 8-digit number, right? So we have 9 choices for the first place. Then for the second place, we have 10 choices, but we don't want the repetition, so we will not use a digit that has already come at the first place. So out of the 10 choices, one has already gone. Now we have 9 choices. Now for the third place, these two numbers cannot come, so we have 8, then 7, then 6, then 5, then 4, then 3, and then 2, right? So this will be your answer. Now from 9 to 2, we can use 1 also. So it's not necessary, but 1 will not make any impact. So 1 into 9, that is 1 into 2 into 3 till 9, it is 9 factorial, and this is 9. So your answer is 9 into 9 factorial, right? You will not be able asked in examination to multiply all these data. So your answer will be in this format only, right? Because it's bit time consuming to make this calculation. So just have the answer in this format, right? So now we are clear how many 9-digit numbers of different digit can be formed. So this is the solution to the problem, right? Now friends, let's do this question. How many numbers are there between 100 and 1000 such that 7 is in the units place? Now 100 to 1000, that means we are asked about the 3-digit numbers, right? 1, 2, 3. Now for the units place, we have the single choice that only number 7 can come. So I put 7 at the units place and I have one choice only. So I just write one choice over here. Now these two places, see, in all we have 10 choices of digits, that is 0 to 9, right? But for the first place we cannot write 0, so I have just 9 choices, right? I cannot use 0. Now there is no restriction on repetition because it's not specified over here. So for the second place I have 10 choices. Any number from 0 to 9 can come. So for the first place I have 9 choices, and for the second place I have 10 choices, and for the third place I have just one choice, right? That is number 7 can come. That means I have just one choice. So in all, 9 into 10, 90 numbers will be like this when 7 is at the units place. Clear? Now, how many 3-digit numbers can be formed without using the digits 0, 2, 3, 4, 5, 6? That means in all we have 10 choices and we cannot use 1, 2, 3, 4, 5, 6 numbers. So 3 places are there. For every place we have 4 choices, right? Because we cannot use 1, 2, 3, 4, 5, 6 numbers. So for the first place I have 4 choices, for second place 4 choices, and then 4 choices, right? There is no tension of 0 because 0 is already not included. So 4 into 4 into 4, that is 64 numbers will be there without 0, 2, 3, 4, 5, 6 out of the total 3-digit number. Now how many 3-digit numbers are there? You can calculate that quite easily. 9 choices, 10 choices, 10 choices, that is 900. So in all there are 900 3-digit numbers, and in 64 numbers you will not find any of these digits, right? Now let's take this problem. How many 3-digit numbers more than 600 can be formed using the digits 2, 3, 4, 6, 7? Now further we have to make the 3-digit numbers, and the restriction is there that the numbers should be greater than 600, right? So we have the 3 places, right? Now for the first place we have just 2 choices, that either number 6 or 7 can come, right? Because what we want the numbers to be more than 600, right? So the first digit should be either 6 or 7. So we have 2 choices for the first digit, right? Then at the second place any of the number can come, so we have 5 choices, right? Because there is no restriction on repetition, so we can take the 5 choices over here. Then similarly on the third place we still have 5 choices because any of the number can come, right? So 5 into 5, 25, 2s are 50. So in all 50 numbers will be there more than 600 which are formed by these 5 digits. Okay. Now the next question is, how many 3-digit odd numbers are there, right? Now in all we know that there are 900 numbers of 3-digit, and definitely 50% of the numbers are odd and 50% of the numbers are even, right? But how do we calculate that? 1, 2, 3. We have 3 places. For the first place we have 9 choices because out of 10 digits we cannot use 0 because we have to maintain the 3 digits, right? So it's 9 choices. For the second place we have 10 choices because now we can use 0. For the third place we have the 5 choices, that is number should be 1, 3, 5, 7 or 9, right? Because if at the unit place if any of these number is there, then only it will be an odd number, otherwise it may be an even number also, right? So we have the 5 choices. So 9 into 10, 90 into 5, 450. That means 50% of the numbers are odd and 50% of the numbers are even. Now the other thing is, suppose we don't want the repetition, right? We want 3-digit odd numbers with each digit should be distinct, right? Now how do we do that problem? For the first place we have 9 choices, right? For the second place we have, how many choices do we have? So for the second place, because we don't want the repetition, we have still 9 choices, right? Because the number which we, or the digit which we have used over here will not be used over here. Now for this place we have to calculate for this place. Now see, at this place 1, 3, 5, 7, 9, any of the digit can come, but we don't want the repetition. So I just explain you the procedure. How do we go step by step? Just wait. Now further listen to me once again. How many 3-digit numbers, odd numbers are there with all the 3 digits are distinct, right? 3-digit odd numbers with distinct digits, right? Now for the units place I have these many choices, 1, 3, 5, 7, 9, right? Now I take one by one. I take one incident, then I multiply it by 5, right? So 1, 2 and 3. Suppose I have number 1 at this place. So I have just one choice, that number 1 is at this place, right? Now for this place I have 0 to 9, 10 choices, but 0 cannot come, so I have 9 choices only, right? Now further listen to me. I don't have 9 choices. Why? Because I have already used up number 1 over here, right? Getting me? And I cannot use the digit, so I cannot use number 1. So I cannot use 0, I cannot use 1, so I have 8 choices over here, right? Now for the second place, I have 10 choices from 0 to 9, but I cannot use 1. 1 cannot be used. Then I cannot use the digit which I have already used over here, right? So further I have 8 choices, right? And at the third place I have single choice, that is number 1, right? So in all 8 into 8, that is 64 choices, right? When the unit digit is 1, right? Now similarly When the unit digit is 3, further we have 64 choices for 5, 64 for this, 64 and for this 64. So in all 64 into 5. So 320 numbers will be there which are odd as well as the 3 digits are distinct, right? So I hope you are clear. This is a really nice concept. Now let's see this question. How many natural numbers less than 1000 can be formed from the digits this when a digit may be repeated any number of times? Now friends, we have to calculate 1 digit number, 2 digit number and 3 digit number as well, right? Because the number should be less than 1000, but there is no restriction on number of digits, right? So 1 digit number, 2 digit number and 3 digit number, right? Now I choose 3 places. Okay. Now at the first place, 1, 2, 3, 4, 5, 6. I have 6 choices, right? Further, at the second place, still I have 6 choices because there is no problem of repetition. The digit can be repeated. And for the third place, still I have 6 choices that any of this digit can come. So in all, I have got 216 natural numbers which are less than 1000 and can be formed with these 6 digits, right? So according to the calculation, the answer is 216, but you think this is the right answer? No. Friends, it's not the correct answer. There is a twist. What's the twist? See, we have chosen 6, we have taken 6 choices over here, and over here. Now we have to think that if all the 3 places are filled up by 0, then what would happen, right? Because here 6 choices, that means 0 can come. Here 6 choices, that means 0 can come. And here 6 choices, that means 0 can come. So we need to deduct a choice or an option where all the 3 places are 0, right? So in all, 215 is the correct answer, right? So if the 2 places are 0, we will be getting a single digit number. If the first place is 0 and the third place is 0, then we'll be getting 2 digit number, right? If the first place is some number and the other places are 0, then also not a problem. But the 3 digits or the 3 places simultaneously cannot be 0. So we deduct that one way, so we get 215 as the correct answer, right? It's very, very important because in options, if you're appearing for any competitive exam, in options you may be getting 215, 216 both as well, right? So be very, very clear about the concept. Now, how many 3 digits numbers can be found by using these digits, which while each digit may be repeated any number of times, right? Friends, we are taking different problem based on numbers. So your concept will be cleared after, I think, so many problems. Now we have 3 choices and we want the number to be 3 digit. Be very clear. Now we have how many choices? 1, 2, 3, 4, 5 choices. So the first place can be filled up with, we have 5 choices for the first place, but we cannot use 0. So we will have 4 choices, right? For the second place, we can use 0. So, and there is no tension of repetition because repetition is allowed. So still we have 5 choices. At the third place, we have 5 choices, right? So in all, 100 numbers will be there formed with these digits, and each digit is maybe repeated, right? Now let's change the flavor here. In how many ways can 4 prizes be distributed among 5 students when there are 3 conditions, right? And so we'll be getting the different answer for all the conditions, right? So let's take them one by one. In how many ways, and just listen to me carefully and try to concentrate. In how many ways can 4 prizes be distributed among 5 students, right? When no student get more than 1 prize. That means suppose the 4 prizes are maybe A, B, C, D, whatever, right? So for the first prize, we have 5 choices, right? Now first prize has been given to any one of them, right? Now for second prize we have only 4 options. Why? Because we cannot give the second prize to the person who has already got a prize, right? So for the second prize we have 4 options, right? Similarly for the third prize we have how many options? Because we cannot give the prices to the first two persons, so we have three choices. Then for the fourth price we have two choices, right? So it's 5 into 4 into 3 into 2, we can say it's 5 factorial, right? Just see the difference among these three conditions, right? Now it's 5 into 4 into 3 into 2, right? When nobody is getting more than one prize. First prize 5 choices, second prize 4 choices, third prize 3 choices, fourth prize 2 choices, right? Now see this. A student may get any number of prizes. Now just see the difference. For the first prize, we have how many options? 5. For the second prize, now a student may get any number of prizes, so still we have 5 choices, right? Now, for the third prize also we have 5 choices. For the fourth prize also we have 5 choices. So in all it is 5 raised to 4. That means 625 ways are there, right? Now the third thing is no student gets all the prizes. Now, what would we do over here? See, in this case, just concentrate over here. It's 625. That means every prize can be given in 5 ways, right? Now, just listen to me carefully. Maybe there are 5 persons, say A, B, C, D, and E, right? Now, in this case, that is in 625, one case will be there when all the prizes are A is getting, right? All the prizes are obtained by A, right? One case. Then all the prizes B is getting. Second case, all the prizes C is getting. Third case, all the prizes D is getting. One more case, and E. So in all, 5 cases are there when all the prizes are given to one particular person, right? Maybe all the prizes are by A, by B, by C, by D, or by E, right? So in all, we need to deduct 5 cases when all the prizes are obtained by one particular person. So in all 625 ways are there minus these 5 ways. So in all 620 ways are there when no student is getting all the prizes because we deducted these 5 cases, right? So I hope you are clear. Now let's see this question. How many 3 letters word can be formed using A, B, C, D and E if repetition is not allowed? Now we have the 3 choices, 3 places to be filled up, 1, 2 and 3. For the first place we have 5 choices, right? But we don't want the repetition. So for the second place we have 4 choices, and for the third place we have 3 choices, right? So in all 60 words can be formed. Now if repetition is allowed, we have 5 choices at every place. So it's 125, right? So you got the difference when repetition is not allowed and when repetition is allowed, how we have to proceed. Okay. Now let's see this question. In how many ways can 5 different balls be distributed among 3 boxes? Now for the simple problem, we have the 3 boxes, maybe A, B and C, right? Now for the first ball, we have the 3 choices, right? We can put the ball in any of the boxes. For the second ball, still we have 3 choices. For the third ball, we have 3 choices. For the fourth and for the fifth. So in all 3 raised to 5 ways are there to put these 5 different balls in any of the boxes, right? Friends, in all these cases, the cases are included when all the balls are in first box or in second or all in third, right? All the cases are included, but since no condition is given over there, so we are taking all the cases, that is 3 raised to 5, right? Now, in how many ways can 7 letters be posted in 4 letter boxes? Now, problem is quite similar. We pick up the first letter, we have the 4 choices, right? We pick up the second letter, still we have 4 choices. We can put the letter in any of the boxes. So for every letter, we have 4 choices, right? So we have 4 is to 7 ways to do this, right? It's quite a simple problem, so be very, very clear about it. And further, the cases are included when all the letters are posted in any of the boxes, right? Maybe A, B, C, D, all the letters are in A or in B or in C or in D. So each and every case is included in this 4:7, right? So if the condition is given like all the letters should not be posted in a single box, then we need to deduct some cases, right? That we will see when we get the problem. Now let's see this problem. A team consists of 6 boys and 4 girls, and other has 5 boys and 3 girls. How many single matches can be arranged between the two teams when a boy plays against a boy and a girl plays against a girl? Now there are two events and the two events are individual, right? From this team, 6 boys, and they have to play against these 5 boys, right? So how many combination of boys we have? That is 6 into 5. Right? So combination, boys combination, right? So we have this 30 combinations, right? Now these 4 girls have to play against these 3 girls. So how many choices or combinations we have? 4 into 3. That is 12. Now we have 30 combinations of boys and 12 combination of girls. But both the combinations are individual, right? They are not dependent or they are not simultaneous event. Okay. So in all we have 30 combinations for boys and 12 combinations. So 42 combinations or 42 teams or single matches can be arranged between two teams when a boy plays against a boy and a girl plays against a girl, right? Be very, very clear and about this concept, right? Just revise it if you are not clear for the first time, right? Just repeat. One boy of this team has 5, then second boy 5 choices, third boy 5 choices. That's why we are taking 6 into 5, and for girls 4 into 3, right? Now let's see this question. There are 5 books on mathematics and 6 books on physics in a bookshop. In how many ways can a student buy a mathematics book and a physics book? That means 2 simultaneous events are there. He has to buy 2 books, one of maths and one of physics. So one book of math, that means he has 5 choices, and simultaneously he has to buy one book of physics, so he has 6 choices. So 5 into 6, 30 combinations he can get, right? Or 30 ways he is having. Now either a mathematics book or a physics book, that means he has to buy only one book. Here 2 books were there and here 1 book is there. Now he has how many choices? 5 plus 6, that is 11 books he is able to see, and out of this 11 book he has to choose one book, right? So either a mathematics book or a physics books, we have 11 ways, right? You got the difference between these two? Here the 2 books are being purchased, here only 1 book is being purchased. So there is the difference in the situation, right? Now let's try this question. How many numbers of 6 digits can be formed from the digits 0, 1, 3, 5, 7, 9 when no digit is repeated, and how many of them are divisible by 10? Right? First of all, we have to create 6 digit numbers and we have 6 digits only. So for the first place, we have 6 choices, but we have 6 digits and we have 6 choices, but if we put 0 at the first place, the number will be of 5 digits, not of 6 digits, right? So how many choices do we have for the first place? It's 5, right? For the second place, in all we have 6 choices. Now 0 can come. So now we have 6 choices, but we cannot use the number or the digit which we have already used at the first place, right? So out of 6, 1 has gone, so still we have 5 choices. For the third place, we are having 4, then 3, then 2, and then 1, right? So these are the number of cases when we can form the 6 digits and no digit is repeated. So this is for this is 5 factorial into 5. What 5 factorial is? 120 into 5, that is 600, right? Now, how many of them are divisible by 10? Now, if the numbers are divisible by 10, at the units place we should be having a 0. Now we have to calculate the number of numbers when the unit digit is 0. So 1, 2, 3, 4, 5, 6. Now at the units place I have one choice, that I can have the number 0 over here, right? So I just have one choice. For the first place we have 5 choices because we are not using 0, we cannot use 0, and we are using 0 in fact at the units place. So I have 5 choices. Now for the second place we cannot use 0 and we cannot use the number that has already come at the first place. So I have 4 choices, then 3, then 2, then 1, right? So it's 120. That means out of the 600, 120 numbers are there when there is no repetition of digit, and all of these numbers are divisible by 10 because we are having 0 at the units place, right? So I hope you are clear. Now let's take this problem. A letter log, I think it's log. A letter log consists of 3 rings, each marked with 10 different letters. In how many ways it's possible to make an unsuccessful attempt to open the log? Now for every place we have 10 choices as given over here. So in all there are 1000 combinations will be there, and out of these 1000 combination, one and only one combination will be correct, that will open that log, right? So out of 1000, one combination is correct, so remaining 999 combinations will be incorrect. So remaining 999 will be unsuccessful attempt to open the lock, right? Quite an interesting and simple problem, right? So friends, we have discussed good number of problems in this session. We'll take more problems based on counting, and we'll start taking permutation and combination as well, because so far we haven't used the terms permutation and combination. So from next session we'll be start taking the concept of permutation and combination as well, right? Bye bye.